Welcome to The Explainer. Today, we're gonna crack a code. But it's not a computer code. It's one that's hidden right inside the sentences we use every single day. It turns out the way we talk is built on a logical foundation that is way more powerful than you might think.
Okay, let's kick things off with a little puzzle. Take a look at this sentence. Most men and most women admire each other. Now, on the surface, that seems totally straightforward, right? But as we're about to find out, the logic hiding underneath, well, it's surprisingly tricky, and it reveals something profound about how our language actually works.
So to really get why this is such a cool puzzle, we've got to first look at the standard toolkit, the tools that logicians use to take language apart and see how it's built. These are the classics you might have bumped into in a logic class. Words like all, some, or none. They call them monadic because they only bind one variable at a time. That just means they're looking at the properties of one single group. For example, if you say all birds fly, you're really just talking about the set of birds. Simple enough. Okay, so that's the basic toolkit. It works great for those simple one-group statements. But watch what happens when we try to use those same tools on our puzzle sentence. Yeah, it's like trying to jam a square peg into a round hole. It just doesn't work. See, monadic logic is, well, it's linear. It handles one thing, then the next. But our sentence? No way. It's got two groups, most men and most women, and they're tangled up in this complex mutual relationship. The simple tools just, they break. They can't handle it. So this wall, this point where traditional logic just stops and can't go any further, it actually has a name. It represents a kind of boundary for that simple linear way of thinking. It's called the Frege boundary. You can think of it like a line drawn in the sand. On one side, you have all the simple sentences that you can analyze piece by piece. But on the other side of that line, that's where things get interesting, and that's where you need a totally different, more powerful kind of logic. And this is the key insight. Our puzzle sentence, most men and most women admire each other, lives beyond the Frege boundary. So what does that really mean? It means you can't just break it down into a simple chain of smaller thoughts. Its meaning is, well, it's fundamentally more complex. It's a single, irreducible idea. Okay, so how do we cross that boundary? How do we make sense of these more complex sentences? Well, we need a better key, a more powerful one. And thankfully, some really brilliant logicians, guys like Andrzej Mostavsky and Per Lindström, they came up with one. And here it is. It's called a Polyadic quantifier. And this thing is designed specifically for this kind of heavy lifting. Instead of looking at just one group, it grabs multiple variables at the same time, which lets it analyze the relationship between the groups. It's a tool that's literally built to handle complexity. All right, so now we've got the key. Let's use it to unlock not just our little puzzle, but a whole bunch of other complex things we say every single day, usually without even realizing how complex they are. And this is a really big deal, because it's not just about one quirky sentence. Polyadic quantifiers are essential for understanding all sorts of things. You've got branching sentences, like our puzzle. You've got reciprocal phrases, each other. Even statements like, 3 boys invited 4 girls. Think about that one. You can't really pin down which boy invited which girl, right? It's a group-to-group thing. This tool is absolutely fundamental to how we build meaning. So how do linguists and logicians actually prove a sentence is this complex? Well, they run a little test. It's called a reducibility test. They basically try to rewrite the sentence using only those simple one-at-a-time quantifiers. And if they can't do it, if there's no way to break it down without completely changing the meaning, then they know. They know the sentence is irreducible. It's officially non-Phrygian. Okay, so logicians, Frege, Polyadic quantifiers. This is all super interesting. But why should you care? Well, because it tells us something absolutely mind-blowing about our own brains and the language we use every single second. Here's the big takeaway. Every single time you hear and understand a sentence like most men and most women admire each other, your brain is performing this incredibly sophisticated logical calculation. You are, without even thinking about it, operating beyond the Frege boundary. The software running in your head is more powerful than basic, first-order logic, and you don't even notice. It's just effortless. And that really is the magic of it all, isn't it? Our language isn't just a jumble of words we've memorized. It's this deeply elegant mathematical system. And using these tools doesn't just solve logic puzzles, it helps us see and appreciate the incredible hidden architecture that's encoded in the way we talk to each other every day. So it leaves us with this one, final, really fascinating thought.
If all of this complexity is hiding in just one simple-sounding sentence, what other incredible logical systems are humming away just beneath the surface of the words we use every single day? It kind of makes you want to listen a little closer, doesn't it?